Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about GRE mathematics subject test, and this is part 2. We're actually at calculus right now, and this is section 1, which is going to talk about limits of sequences. So let's go ahead and get started, guys. Now, what about limits of sequences? So let me just go ahead and give you a brief introduction to the theory. Now, first of all, before I start, more than 50% of the questions in GRE mathematics subject tests are from calculus. So that means calculus is the most important section for GRE mathematics subject test. All right, so right now we're just going to focus on single variable calculus. So this video and some videos in the future are going to be about single variable calculus. And then we are going to introduce multivariable calculus as well. Okay, so let's start. So first of all, let's say that there is a sequence, right? So there is a sequence, and that sequence has x1, x2, all the way till n variables. So we have a sequence of n numbers, right? So what is the limit of a sequence? What do you understand by limit of a sequence? By limit of a sequence, I mean that what is going to happen to the last value of the sequence as n approaches infinity. As n approaches infinity, what is going to happen to xn? Is it going to converge to a number, a constant, or is it going to keep on diverging or keep on going further? Right, so my question is, we have to find out is whether a series is converging to a particular constant or is it diverging away and away and away. Let's say, for example, if I have a sequence, let's say that sequence is 2 minus 1 over n, right? So what is the first term? The first term is 1. What is the second term? The second term is 2 minus 1 over 2, which is 2 minus 1 over 2, which is 3 by 2. What is the third term? That is 5 by 3. Now, what is going to happen as n approaches infinity? Now, as n approaches infinity, I would like to call that limit n tends to infinity x of n. This is what we call limit of a sequence. So where does this limit go? So as n approaches infinity, 2 minus 1 over n is actually going to be, as n approaches infinity, 2 minus 1 over infinity. Anything over infinity is going to approach to 0. So that means this limit is going to approach to 2. So that means as you keep going further and further, as I go from x4 to x5 to x6 all the way till x100 or till x1,000,000 or x1,000, the limit is going to approach 2 as n approaches infinity. So this is an example of a converging series, right? So I hope you got that, guys. Now there are two types of series, right? So there are two types of sequence. There are two types of sequence. The sequence can be a convergent sequence. It can be a convergent sequence. In a convergent sequence, limit n tends to infinity, x of n approaches a constant, right? So that is the definition of a convergent sequence. And then you have a divergent sequence. Now, what is a divergent sequence? In a divergent sequence, it approaches either positive infinity or negative infinity. Let's say, for example, if I have xn to be equal to 2n minus 1. Now, as n approaches infinity, xn also approaches infinity. You can clearly see, as n approaches infinity, this whole term approaches infinity. Or the other example would be, let's say xn is equal to 2n minus n squared. Now, as n approaches infinity, you can see this term over here approaches negative infinity. It goes to infinity, but on the negative side, because this term will always be greater than this term as n approaches infinity, right? Or you can say 2 times infinity minus infinity squared. That's actually going to be negative infinity. So this is kind of a dichotomy or the tree diagram for the sequences, right? But any sequence can either be convergent or it can either be divergent. Or a sequence can be oscillating as well. That it could be oscillating between various terms. It could neither diverge nor converge. Now, what exactly is an oscillating series? So an oscillating series is something that neither converges nor diverges. Let's say, for example, xn to be equal to negative 1 raised to the power n. Now the first term is negative 1, the second term is positive 1, the third term is negative 1, the fourth term is positive 1. So what happens is the series just keeps on oscillating between negative 1 and positive 1. So as n approaches infinity, it's not going to converge or it's not going to diverge, it's just going to oscillate, right? Another type of series are also called monotonic series. Now what's a monotonic series? A monotonic series is a series which either increases or it decreases, right? So if I pick up the other example, let's say the series is xn is equal to 2n minus 1. This series is an increasing series. As x increases, the series keeps on rising, right? But on the other hand, you have xn is equal to 2n minus n squared. This is a series which is a decreasing series. As x increases, the value of xn goes down. Now these both are monotonic series because they're either increasing or they're decreasing. And you would have something as non-monotonic when it increases and then it decreases, right? That would be minus 1 raised to the power n. It is not monotonic. So I hope you got that, guys. I hope you understood. Now there are few rules about convergent series that you should know, right? They're very, very important. What are the rules about convergent series? First thing, convergent series, every convergent series is bounded. What do you mean by bounded? I mean to say that all its terms are going to be less than a particular constant. So every convergent series is bounded. That means any x value is going to be less than any absolute of a value is going to be less than a constant, right? So this is why I mean to say it's bounded. It cannot go more than a constant. That is what the meaning of convergent is. That means as x increases, it converges to a particular point, either decreasingly or increasingly, right? So that means they are always less than one particular constant. Well, that is not true for a divergent series, because a divergent series can actually keep on going to a divergent series, this is not a divergent series, this is a convergent series when it converges to a particular value. But on the other hand, a divergent series will just keep on increasing. You cannot bound it by a particular constant. But the reverse may not be true. I mean, you cannot say that a series is bounded, that means it is going to be convergent. Take my negative 1 raised to the power n, for example. This is a bounded series. Why? Because it is always going to be less than or equal to 1, right? So this series is bounded, but it is not convergent. So every convergent series is bounded, but every bounded series may not be convergent. Second thing is that if a series is monotonic and bounded, so if it is monotonic, that means it's constantly increasing or decreasing, and it's bounded, that means the series has to be convergent. And that makes sense, because if it is constantly increasing and it's bounded, that means it has to be convergent. The third rule that I would like to say is that if a series converges to a constant, right, then a constant multiplied by the series will converge to constant multiplied by the constant. So if an converges to a, then k times an will converge to k times a. This is also pretty important. Another rule, which is rule number 4, that I would like to state is, let's suppose a series converges to a constant and another series converges to another constant. Then it follows the additive rule. The addition will actually converge to this constant. The subtraction will converge to this constant. The product will converge to this constant. The division will converge to this constant, provided that b is not equal to 0. Right? So that's a very good rule. Another thing, if k is greater than 0, it's kind of a standard rule, then and k is a constant, then 1 over n raised to the power k will converge to 0. And that makes sense, because 1 over 1 raised to the power k, 2 raised to the power k, 3 raised to the power k, this is going to converge to 0, because 1 over infinite raised to the power k is actually going to be 0. Another rule is, one of the last rules, is that if k is greater than 1, absolute of k is greater than 1, then 1 over k raised to the power n will converge to 0 also. Because 1 over k raised to the power 1, 1 over k raised to the power 2, 1 over k raised to the power 3, that is going to converge to 0. I hope you're getting this point here, guys. I hope you're understanding this. Right? That's pretty easy. Just make sure that you keep this in your mind. Right? Another thing that I want to say is, another rule that I want to say is, let's suppose, which is known as the sandwich theorem. What does it say? It says that, let's say you have a series converges to a constant. You have another series, let's say Cn. It also converges to a constant. Let's say there is another sequence Bn, and that is actually between Cn and An. Then this Bn is also going to converge to a constant because it's going to get sandwiched between An and Cn. So what I mean to say is that if there is a series sequence An converging to a constant, sequence Cn converging to a constant, and there is a sequence Bn which is between An and Cn, then Bn is always going to converge to that particular constant. And another thing is, another important rule is that if An is a function of n, right? It could be any function of n. Now this An is going to converge to a constant if this particular function converges to a constant as x tends to infinity. So we're going to talk about the rule of this in the coming videos, but this is something that you should know, that if a series An converges, it's a function of n, then this series is going to converge to a constant if this function itself converges to a constant as x tends to infinity. So these are the rules that I want you to know, that these are the rules that are very, very important. Now what I'm going to do is I'm actually going to solve some questions. I'm going to show you how do you use these rules to find out which series is which converges or it does not converge. Okay, so let's see some questions here. Okay, so let's see this question whether this series converges or not. So what do we have? We have xn to be equal to 4n cube minus n square plus 5n divided by 2n cube plus 6n square minus 11. Well, when you have something like this, what you do is you try to get rid of the n's as much as possible. So what I'm going to do is, the highest degree of n is n cube. So I'm going to divide the equation by n cube and I'm going to multiply the equation by n cube. I'm going to divide both sides as by n cube. So what do I have? I have 4n cube over n cube minus n square over n cube plus 5n over n cube divided by 2n cube over n cube plus 6n square over n cube minus 11 over n cube. So you can see that xn turns out to be 4 minus 1 over n plus 5 over n square divided by 2 plus 6 over n minus 11 over n cube. Now as n approaches infinity, this thing becomes 4 minus 1 over infinity plus 5 over infinity square, which is just infinity, 2 plus 6 over infinity minus 11 over infinity. Now there's one thing, that anything over infinity is 0. It's 0. So this is 0, this is 0, this is 0, and this is 0. So we're just left with 4 by 2. That means this thing converges to 2. Right, very easy. I hope you got that, guys. Let's move on to the next one. Now let's see this question here. Let's see whether this converges or not. Now we have k as a constant and we have square root of n. Now first thing that I want to do here is, if I say n goes to infinity, I can clearly see this goes to infinity, like infinity plus k minus infinity. Now that might not go to infinity. I'm not sure. So first thing what I want to do is, I want to get it out of the what do you say, square roots. I want to rationalize it. So what I'm going to do is, I'm going to divide by square root n plus k plus square root of n. I'm going to multiply by square root of n plus k plus square root of n. So what I'm doing here is I'm rationalizing it, right? So this is what I'm doing. I'm doing rationalization. So xn of n becomes a minus b into a plus b, that is a square minus b square, right? Divided by square root of n plus k over square root of n. And n, you know, is a positive integer because that's just n. So this goes out, so I'm left with this is equal to k over square root of n plus square root of n plus k. Now, if you've seen the conditions of convergence that we've shown in the first section of this video, I showed you that 1 over n raised to the power half will converge to 0, because that's what it is. 1 over n raised to the power k converges to 0, right? That is what I said that. Another thing is that k over n square root of n is always going to converge to 0 as well, because if this converges to 0, this will converge to 0, right? Now, if I use the sandwich theorem, what does the sandwich theorem states that? Well, that makes me want to eat a sandwich now. So what does the sandwich theorem say? It says that if 1 over square root n converges to 0 and k over square root n converges to 0, what about k over square root n plus square root n plus k? Now this is a value which is between these two values. Now this is greater than this and this is greater than this. You can easily verify that. You can see that k over square root n is going to be greater than k over square root n plus square root n plus k, which is going to be greater than 1 over square root n over square root n plus k and k. So you can see that this is greater than that, right? Because this relationship is pretty clear, but you'll have to work a little bit on understanding this relationship, which is going to be greater because square root of n plus k will remain less than k, right? So this is sandwiched between these two values. So that means that if this approaches 0 and this approaches 0, this thing has to approach 0, right? So using the sandwich theorem, we can state that this approaches 0. So I'll just repeat what I did here. So we had this expression here. I want to get rid of the under roots, square roots. So what I did was I rationalized it. Once I rationalize it, I'm left with this. Then I try to use the sandwich theorem. I said this approaches 0 and this approaches 0. And this is a value which is between these two values. That means this approaches 0 as well. Hope you got that, guys. I hope you understood it. Let's move on to the next one. Okay, so we have this series here. Now, what is x of 1? X of 1 is just 1 over 2, right? And what is x of 2? X of 2 is 1 over 2 into 3 over 4, because that's the second term. What is x over 3? That is nothing but x over 2 times 5 over 6. So what's happening here? You can clearly see that the series is monotonic and it's constantly decreasing. Every term that you multiply is less than 1. That means it says that it constantly decreases. This is 1 by 2. This is 1 by 2 into 3 by 4. This is the previous value into 5 by 6. This value is less than 1. So that means this value is a decreasing series. Now, another thing that you should know, that this series is bounded. When I say bounded, xn is always going to be less than 1, because the greatest value is 1 by 2. Because then the next value is 1 by 2 into 3 by 4, which further reduces it. And then the next value is the whole thing into 5 by 6. It further reduces it. So we have a series which is monotonic and we have a series which is bounded. That means what? That means if a series is monotonic and if a series is bounded, it has to converge. Right? So that means this series also converges. The sequence also converges, right? Moving on to the next one now. Now we have this series here. As you can see, 1 over n square is going to converge to 0 because 1 over infinity goes to 0. So if 1 over n square converges to 0 and the negative 1 over n, negative 1 raised to the power n is not going to change its value, right? So it's either going to be positive 1 or it's either going to be negative 1, right? So and this multiplied by 0 and this multiplied by 0 is going to converge to 0. So that means this series xn is going to converge to 0. So this is kind of an oscillating series, but it still converges to 0, as you can see because of this term right here, right? So hope you got that, guys. Moving on to the next one. Okay, so we have this one here. So if I want to write it in a normal form, so this is cos of n raised to the power n divided by e raised to the power n. Now this thing over here is always going to be between 1 and minus 1. So because cos theta is always between 1 and negative 1. And this thing over here, 1 over e raised to the power n, this is something which is going to converge to 0, because 1 over e raised to the power infinity is going to be 1 over infinity, which is going to converge. So we have 1 over e raised to the power infinity, which is going to go to 0, and this is a bounded value. It's going to stay from 1 to -1, which means that xn is going to converge to 0. Right? Because you have a function which is you have a function which is 1 over e raised to the power n that converges to 0, and you're multiplying it with just a number between 1 and -1, so it has to converge to 0 because one of them is converging to 0. Right? So you could use and prove this more formally using sandwich theorem, but in GRE mathematics subject test, the answer is what that matters, right? So I don't have to prove this formally. So I hope you got that, guys. Thank you very much for watching this video. I really appreciate it. Make sure that you give us your valuable feedback at this email address, that is support@perfectscores.org, and explore more about us, that is perfect-scores.com, and give us your valuable like on our Facebook page, which is facebook.com/perfectscores, and also follow us on other social media platforms like Twitter and Instagram. So thank you very much for watching this video. I'll see you in the next one.